divide both sides?
Or divide, multiply?
Yeah.
I don't know, what did I do? Okay, I did multiply, good.
Yeah. I mean, you can divide by a fraction, but it gives you one more step that you have to do, which multiplying by the fraction just goes ahead and eliminates. Remember, whenever we have more steps, it increases the likelihood of our making an error. So we want to decrease the number of steps. Keep going.
And then, I'm trying to see through this jumble of work. Because I just did each problem along the line and they're just right under each other.
Okay, so you just multiply across? You just went 4 times 72 and 3 times 10?
Yeah, I think so.
Okay.
Except I know I canceled.
Okay, good, you canceled. Well, let's do the cancellation, because otherwise we're going to get some really big numbers here.
Yeah.
Now,
Are you copying this down?
when we cancel, where'd you begin?
We cancel the 4 and the 10,
Giving us,
2 and 5.
and do we stop there?
No.
Hmm?
No.
Keep going.
I forget how many times 72 can be divided by 3.
Well, let's not think of that. Let's think about how many times 3 goes into 7.
Watch.
Or 2.
Okay.
There's a remainder of 1. How many times does 3 go into 12?
4.
So what we have right now is C is equal to 2 times 24 over 1 times 5. Let's do this. Rem, let's go ahead and multiply from left to right instead of from right to left. What's 2 times 2?
2 equals 4.
2 times 4?
8.
1 times 5?
5.
Lauren, your task for us will be, now if you're doing this for me, I have no problem with that, because that's the lowest you can reduce that fraction, is 48/5. And that's the way when you use fractions in your work, you're not going to convert to mixed numbers. But your book wants you to work with mixed numbers. Please convert for us into mixed numbers. How many times does 5 go into 48? Good. 9. 5 goes into 45, 48 9 times. 9 times 5 is 45. 48 minus 45 is 3. What the heck am I doing? And 3 fifths. Is that what you had?
Yeah.
Excellent.
Except I didn't have it as a mixed number.
You just left it as an improper fraction.
Yeah.
Okay. I have no problem with that. The book does. The book, until you go ahead and get into algebra, wants you to go. So what I would suggest is you do both. Improper fraction and mixed number. I know it's one more step over, right? Next one, number 7. The difference of, let's stay on number 5, the one we just did. Because you went with the fraction. I wouldn't have. I would have gone with the decimal.
Not very good at decimals.
Okay, well, but that's good. In other words, you find out what you're good with, and that's what you work as your primary way of doing it. When we get into the fraction, the decimals, and the percents, and you're going to have to make conversions, you rely on the one that's your strength. And if you know you're better at fractions than you are at decimals, you stay with fractions, but you use the decimals to check your work. Right?
I got the same answer as you for this one, except I got it in a bigger form and I just divided it by 3.
How did you do it? Want to explain your work? Or better yet, you want to show us your work?
It's kind of small.
Up on the board. That's what we're here for. You
I
raise
don't
them.
remember how I did it.
Well, then
You
bring
take
your
it up with you.
notebook with you. Because I would have done it in a completely different way. I would have taken the 3/4 and turned it into 0.75. And then I would then go ahead and take the 0.75 and then go ahead and divide it from one side. But that's just how I would do it, because it just seems...
See, the way I see it though is if you're better at doing the problem one way,
Yes.
then wouldn't you check it that way instead of checking it the way you're not good at? Because if you got it right the first time, and then you check it with the way you're not so sure you can get it right with, then if you get a wrong answer when you're checking it, you think the right answer is wrong.
Okay. Let me do this. let me go ahead and give you a sports analogy. Say, for instance, you're playing a really good team, a real challenging team, and you have one play that you know that works all the time and one play that works like 3/4 of the time. To beat that team, do you go ahead and use the play that works 3/4 of the time or the play that works all the time?
All the time.
Yeah. You go to your strength. Unless you want to bluff. And math's not poker. Though, you need to having math skills will help you with poker. So that's what I do, is I use what I feel most comfortable to solve the problem because I'm pretty sure I'm going to get the right answer. And then I check with the second one. And if the process of checking says, well, gee, something doesn't look right, I go back and I redo the same work according to the first way I did it. And if I get the same answer, then there's a better possibility that my first way is more right than my second way. Okay. If you will, Lauren, please don't leave. Walk us through it. What did you do step by step?
First I turned 7.2 into a fraction. And then I multiplied 3/4 by its reciprocal. And then I multiplied, then I reduced 72/10 by half.
Okay, Rem, do you see what Lauren's done for us? Slide over a bit. What Lauren first does is Lauren first reduced. She did the same thing you did. She went to the fraction, but she reduced. Okay? And then what you're doing is now you're multiplying by the reciprocal, right? And 12/12 is just 1, right? Now, when you did this, explain what you did over here. Explain what you did over here.
I multiplied 36 by 4 and 5.
Okay, so when you did this, you specifically multiplied 36 by 4, and then you multiplied 5 by 3, right? And that ended up giving you 144/15, right? Did you do that math in your head, or did you do it on paper? Okay. This is a tricky way of doing stuff, because it opens up the possibility of making mistakes. What I'm trying to do is I'm trying to give you as easy a way of solving it as possible. To me, the easier way would have gone ahead and been to use the decimal, but you went ahead, you opted in both instead for the fraction, which is completely fine with me. Would you have done it this way?
I don't know.
In other words, when you're doing this, Lauren, you're doing stuff north and south, right? North to south. I place them east and west, because when I do so, it allows me to cancel for my multiplication problems.
Yeah, I don't think I would have done it this way.
In other words, this looks really hip for like doing addition or subtraction, but I would just go ahead and like run stuff this way. And each step I would go this way instead of boxing them like in 2 steps. I mean, I'm trying to make it easier for you. That's what matters. Okay, let's see. Rem, if you would, what did you have as an answer for number 7? Negative 2.4n equals 7.2.
The answer?
Yeah.
Was 3 over 1. N equals 3 over 1.
N equals 3.
Yeah.
But what kind?
Negative.
Negative 3, all right? Let's look at number 9. Lauren, take a look at number 9. N minus 0.64 equals negative 5.44. How would you go about solving that one?
I
Okay.
guess I'd just do I'd do 0.61 plus the negative 0.6 of the 4 plus 0.64.
Good. In other words, you have to get the n by itself, correct? How do you get the n by itself for a subtraction problem? You go ahead and add what's being subtracted. Now this is a time I would have gone north and south, Lauren. Directly underneath the negative 0.64, I would have put plus 0.64. And then underneath it I would put the line and then a 0. And then I would go ahead and go plus 0 underneath the negative 5 point, and then 6,4 underneath the 4,4. And then I would go ahead and subtract. And again, if I want to find out what these answers are, I can go ahead and just put them into the calculator. But I want to make sure you understand setup. Rem, number 11. 3/8 equals 1/2 x.
3 equals 1 x. I can't even tell what I did here. It's so small. I think, I'm pretty sure I just multiplied by the reciprocal.
Good.
Of 1/2.
And you ended up with
3/4 equals x.
excellent. In other words, we can see right here that the reciprocal of 1/2 will be 2/1, right? Cancel the 2 with the 8, which is going to give us 1 times 2, and then 1 times 4, 1 times 3, and then 1 times 4, and we add the answer of 3/4. Well done. Sehr gut. Let's go ahead and look at our next lesson, which is going to be on page 126, powers and exponents. If you would, 126, please. Powers and exponents, which will be followed by scientific notation.
100 what?
126, lesson 2-9. And what we're going to try to do is we're going to try to devote 15 minutes to this lesson and then 15 minutes to the next one, because they work the exact same way. Now, what I have over here is I have 3 counting numbers and another 3 rational numbers that are fractions. That's really a cumbersome way to write it, which means it's kind of cluttered. So you know what I do? How many 5s do I have?
3.
This means 5 to the 3rd power. This number over here, the number on the bottom, my counting number or my integer, that's called the base. This over here is called the power. So technically this is the base times the power. 5 to the power of 3. Or if you just want to be more informal, 5 to the 3rd. Okay? Now these over here are 1/2s. So what I'm going to do is I'm going to go like this, 1/2 to the 3rd. I have 3 1/2, so I take 1/2, but I do something to this one that I didn't do to the 5. I place this in parentheses. I could have placed this in parentheses, but I didn't. This one I had to. You know why? Anybody?
Because it's a fraction.
Well, correct. In other words, but this could be a fraction too. This is 5/1, right? We know that any integer can get set up as a fraction. You're right, keep going.
Because those 2 are being multiplied together as well. The 5 and the 1/2.
Okay, stay inside of here. Imagine the 5's not even up on the board.
Alright.
In other words, the question I'm asking is why did I not go like this? Instead I went like